A man pays a loan of 65,000 by paying rupees 400 in the first installment and then increasing the payment by 300 every month. So 400 plus 300, 700 in the next month, and then for the next month increasing 300 and 1000 in the third month, etc. In this way he is paying the loan amount of 65,000. How long will it take for him to clear the loan? How long will it take to him to clear the loan? Now the amount of repayment in successive months are 400, 700, 1000, etc. So 400 plus 700 plus 1000, etc. plus etc. Now for n months, for etc. for n months, n is unknown, we should find the value of n here. So now sum is 65,000, total value he has to pay is 65,000. So Sn equal to 65,000, sum of the total amount. Now the formula for Sn is n by 2 into 2a plus n minus 1 into d equal to 65,000. Here we have a equal to 400 and every month 300 is added, so d equal to 300 or d equal to t2 minus t1, we can take d equal to 300. Substituting in it, we have n by 2 into 2a, 2 into 400 is 800 plus n minus 1 into d value is 300 equal to 65,000. Now cross multiplying these two inside or dividing by 2 inside, listen carefully here, n into 800 by 2 is 400 plus n minus 1 into 300 by 2 is 150. Now multiply 1 by 2, 800 by 2 plus n minus 1 into 300 by 2, cancelling these two, 800 by 2 is 400, 300 by 2 is 150, so n minus 1 into 150 equal to 65,000. If it is divisible by 2, you can divide, else you can cross multiply it, then we can simplify. Here, simplifying it, n into 400 plus multiply inside 150n minus 150 equal to 65,000. Then 400 minus 150 is 250, n into 250 plus 150n equal to 65,000. Multiply inside n, we'll get 250n plus 150n square minus 65,000 equal to 0. Multiply inside n 250n, here 150n square minus 65,000 equal to 0. Look at here, all are divisible by 50. Now dividing it by 50 will get divided by 50 will get 50 here 250 divided by 50n plus 150 divided by 50n square minus 65,000 divided by 50 equal to 0. Cancelling these two, here 5 times n 5n, then here cancelling we have 3n square plus 3n square minus here cancelling we have 5 13,300 equal to 0. Now ordering it, 3n square plus 5n minus 1300 equal to 0. This is a quadratic equation. We should factor it. After factoring we will get the value of n. When we multiply by 3, it should be minus 3,900. When we multiply, the numbers will be minus 3,900. When we add those numbers, the sum will be equal to 5. So we should find these typical numbers. When we add them, we will get 5. And when we multiply them, it will be equal to minus 3,900. The numbers are 65, 60 equal to 3,900. But when we add, we should substitute minus here, put minus here. 65 minus 60 is 5. So we have 3 as a coefficient of n square. So dividing by 3, will get this will be equal to 20. So n minus 20 into n plus 65 by 3 equal to 0. So these are the two factors here. Now simplifying this, equating to 0 the factors, n equal to 20 comma minus 65 by 3. N cannot be fraction and n cannot be negative. So n equal to 20 is the required value. So if he continues to pay in this way, adding 300 every month, when n equal to 20, when n equal to 20, he will complete the loan amount of 65,500. So he can complete the amount of 65,000 in n equal to 20 months. In 20 months, he can complete. Next one. If S1, S2, S3, etc., Sn, etc., Sm are sum of n terms of MAPs whose first terms are 1, 2, 3, etc. M, and whose common differences are 1, 2, 3, etc. 2m minus 1 respectively, then show that S1 plus S2 plus etc. plus Sm equal to 1 by 2 into Mn into Mn plus 1. Show that S1 plus S2 plus etc. plus Sm equal to 1 by 2 into Mn into Mn plus 1. Given S1, S2, S3, etc. Sm are sum of n terms of an AP. For the first sum, A equal to 1 and D equal to 1. For the sum 1, A is 1, D is 1 is taken. For sum to n terms, sum 2, A is taken as 2 and D is taken as 3. For S3, A is taken as 3 and D is taken as 5, etc. For sum to n terms of MAP, mth AP, A is taken as M and D is taken as 2m minus 1. These are given. So S1, S2, S3, etc. Sm are sum to n terms of MAPs. In that S1, for S1, A is 1, D is 1. For sum 2, A is 2, D is 3. For sum 3, A is 3, D is 5. For sum M, A is M, D is 2m minus 1. If it follows in this way, then sum of all the sum to n terms of the APs, MAPs is S1 plus S2 plus etc. Sm equal to 1 by 2 Mn into Mn plus 1 we should prove. Now here for first AP, S1 equal to n by 2, n is unknown, so n by 2, 2a plus n minus 1 into d, 2a plus n minus 1 into d, substituting in it, S1 equal to n is unknown, n by 2 into 2 into a 2, 2 into 1 2, plus n minus 1 into d, d is 1. So S1 equal to n by 2 into 2 plus n minus 1, 1 into n minus 1, n minus 1. Simplifying this, S1 equal to n by 2 into n, 2 minus 1 is 1, so n plus 1. Simplifying this, we'll get n plus 1. So S1 equal to n by 2 into n plus 1. Now for sum 2, A is 3, A is 2 and D is 3. So S2 equal to, applying the same formula, n by 2, 2a, 2 into 2, that is 4, formula is 2a, here a is 2, so 2 into 2, 4, plus n minus 1 into d, d value is 3, so 3 into 3. Now multiply inside, n by 2, 4 plus 3n minus 3, simplifying it, S2 equal to n by 2 into 3n, 4 minus 3 is 1, 3n plus 1, etc. Sm equal to, here Sm equal to, substituting the formula n by 2, 2a is m, 2m plus n minus 1 into d is 2m minus 1. Now multiply inside will get n by 2 into 2m plus, multiply here 2mn minus n minus 2m plus 1. Multiplying the terms here will get these four terms. Here plus 2m and minus 2m get cancelled. So Sm equal to n by 2 into 2mn minus n plus 1. Now if we should sum all these cases S1, S2, S3, etc. Sm, when we add these answers, which we should show that the sum of all these terms is equal to 1 by 2 into all the sums is equal to 1 by 2 into mn plus 1. Now adding the sums, S1 plus S2 plus S1 plus S2 plus etc. plus Sm will be equal to all the terms containing n by 2 as a product. So taking out common n by 2 into, after taking n by 2, here we have n plus 1. In the second case we have 3n plus 1. And in the third we have plus etc. plus in the last we have 2mn minus n plus 1. Here you can simplify this more, taking n as common here, n by 2 into, take n out, then 2m minus 1 into n plus 1. So substituting here 2m minus 1 into n plus 1. So n by 2 is taken out from all S1, S2, Sm all containing n by 2 as a product. So n by 2 is taken out. Remaining in S1 is n plus 1 here. The remaining in S2 is 3n plus 1 I applied here. Then for Sm the remaining is 2m minus 1 into n plus 1. Now look at here. This is n plus 1, this is 3n plus 1, this is 2m minus 1 into n plus 1. Now grouping the nth terms on side will get, so grouping all the n terms which is equal to n by 2 into, here we have n plus in the next term we have 3n plus in the next one is 5n plus etc. plus 2m minus 1 into n and then plus 1 plus 1 plus 1, 1 plus 1 plus 1 etc. all the terms we have 1. So we have m number of terms, we are adding m number of sums. So adding 1 to 1 2 times we will get 2, adding 1 3 times we will get 3, and adding 1 as 5 times we will get 5. Similarly, adding 1 with m times we will get m. So 1 plus 1 plus 1 etc. m, 1 all are added and finally we will get m as the answer. Adding m times 1 we will get m. Adding 4 times 1 we will get 4. Adding 3 times 1 we will get 3. Adding 5 times 1 we will get 5. Adding 100 times 1 we will get 100. Similarly, adding m times 1 we will get m. So all the ones are converted as m here. So taking n as common from these things, here n is taken common from these terms, we will get n by 2 into n into 1 plus 3 plus etc. plus 2m minus 1 plus m. Now look at here. This is the sum of first n odd numbers. First odd numbers. Here sum of first n odd numbers. That means the sum is known as m square. First sum of first n odd numbers is equal to n square we have. So here we have 2m minus 1. So there are m terms here. So sum of first m R numbers will be equal to n by 2 into n into sum of these terms will be equal to m square plus here we have one another m. So taking m as common here, both the terms we have m common taken out, mn by 2 into, here m is taken out, remaining is n into m, and then plus m is taken out, here is remainder is 1. So the sum of s1 plus s2 plus s3 plus etc. So s1 plus s2 plus s3 etc. sm will be equal to mn by 2 into mn plus 1. Therefore, which implies s1 plus s2 plus etc. plus sm equal to 1 by 2 mn into mn plus 1. Hence the result. Look at here. Sum of first n odd natural numbers. Sum of first n odd natural number will be equal to n square. Here this is 2m minus 1, so we have here m number m first n m odd numbers. So sum of first m odd numbers is m square. So 1 plus 3 plus etc. plus 2m minus 1 will be equal to m square. So this fully taken as m square. So when we add odd numbers with the n terms, the sum will be equal to n square. So here there are m terms, we are adding m terms sum, m odd numbers whose sum will be equal to m square. So n into m square plus one another m is here. Taking m as common, we will get mn by 2 into mn plus 1. That is our required answer. Find the sum of a minus b by a plus b plus 3a minus 2b by a plus b plus 5a minus 3 by a plus b plus etc. to 12 terms. So these are the terms given here. Like this type of 12 terms we should sum. So here the first term is taken as a equal to, let it be a here, the first term is a, so a equal to a minus b by a plus b. And d, common difference is taken as capital D, because we have here a, b, c, d, and also I am taking alternatively the first term a as capital A and common difference d as capital D. That is d equal to t2 minus t1. This is second term, this is first term, t2 minus t1. Both are equal denominator, have equal denominator, so we can take a plus b in the denominator. Now subtracting, 3a minus a is 2a minus 2b, when we subtract it, it will be plus b. So minus 2b plus b equal to minus b. So d is 2a minus b by a plus b. Look at here, t2 minus t1, 3a minus a is 2a, minus 2b, minus of minus b, when we subtract it will become plus. So minus 2b plus b is minus b. So this is common difference d. Here n equal to given 12. So substituting sum formula Sn equal to n by 2 into 2a plus n minus 1 into d. Substituting here n by 2, n is 12, 12 by 2, 2 into a is a minus b by a plus b plus n minus 1 into, n is 12, 12 minus 1 is 11 into d, d value is 2a minus b by a plus b, which is equal, this is, we can cancel this by 6 times, 6 into, multiply the numerator, here we have 2a minus 2b by a plus b, and multiply 11 with the numerator, 22a minus 11b divided by a plus b. Now we have both are equal denominator, so 6 into a plus b, here 2a plus 22a is 24a, minus 2b minus 11b is minus 13b. This is equal to 6 times. Now taken a plus b out, this is equal to 6 by a plus b into 24a minus 13b. This is the sum of 12 terms in the given AP. The product of 3 consecutive term of GP is 343. Product of GP, consecutive terms, product of 3 consecutive terms of a GP is 343 and their sum is 91 by 3. Find the 3 terms. Find the 3 terms. Find the 3 terms. The 3 consecutive terms of a GP is 343 and whose sum is 91 by 3. Find the 3 terms. For convenience, we can consider 3 numbers. Let A by R, AR be 3 terms of a GP. Given product equal to 343. So multiplying these 3, A by R, A into AR equal to 343. Here R and R get cancelled. Remaining A into A cube equal to 343. Now 343 will be equal to 7 cube. So A cube equal to 7 cube, which implies the value of A equal to 7. So by given condition of second condition is sum is 91 by 3. Given their sum is 91 by 3. So adding these 3, A by R plus A plus AR equal to 91 by 3. Taken A as common, 1 by R plus 1 plus R equal to 91 divided by 3. Now substituting A equal to 7 in it, we can get 7 into 1 by R plus 1 plus R equal to 91 by 3. Now we can cancel 7 and 91 13 times here, 1 time here, 13 times, and then multiplying it by R will get, multiply by R will get 1 plus R square equal to 13 by 3 R. So 7 1 time, here 13 times, so 13 by 3. 1 by R plus 1 plus R equal to 13 by 3. Now multiply it by R both sides. R by R 1 into R into R square equal to 13 by 3 into R. Now cross multiply 3 plus 3R square equal to 13R. Now grouping one side, forming a quadratic equation, 3R square. Now 3R minus 13R minus 10R, then plus 3 equal to 0. Simplify it, we will get quadratic equation of 3R square minus 10R plus 3 equal to 0. Now when we multiply it will be equal to 9. When we add it will be equal to minus 10. So minus 9 minus 1 are the numbers. Now here divided by 3 we will get minus 3 comma minus 1 by 3. So writing R value, change its sign. So R equal to 3 comma 1 by 3. There are two values for R, that is R equal to 3 comma 1 by 3. Either do it by this way, else by factoring by splitting the middle term you can factorize. Anyway, which one is easy to you can calculate. So here we have R value is R equal to 3 comma 1 by 3. A is 7 but R equal to 3 and 1 by 3. There are two values for R. Now when A equal to 7, R equal to 3, substituting in it, A by R means 7 by 3 comma A is 7 comma AR, 7 into 3, 21. A equal to 7 and R equal to 1 by 3. We have A by R means 7 by 1 by 3, that is 7 by 1 by 3, 7 into 3, 21. And A means 7 and AR means 7 into 1 by 3, 7 by 3. Therefore the numbers are 7 by 3 comma 7 comma 21 or 21 comma 7 comma 7 by 3.